Well, everyone, we're back at it again with the second section now. We're going to be working with a windmill. And in this windmill, we have this point P. This point P is going to be rotating along the center axis, and you can think about this as, once again, your unit circle. So I'm going to go ahead and draw an XY axis, and you guys are going to start to kind of see where this all kind of comes together. So let me go ahead and try to make a circle with this if I remember exactly how to do it. So there we go. And with this, what's going to happen is our function here is going to be rotating around. We have our x and we have our y coordinates. So if you guys recall from this, x is once again your cosine of angle theta, and then your y is sine of angle theta. So with that, what you guys have is a windmill that's going around circles, and we're going to determine what happens as this point P moves. So what we're going to do is go ahead and take a look at some sine and cosine values down below. And if you guys are looking at it, this cosine value, it starts out at 1. Then it goes to 0. Then it goes to -1. Then it goes to 0. Then it goes up to 1 again. So from here to here, this function has just repeated itself. And I'm going to go ahead and go back up to our circle. So when we're looking at it, starts at 1. That's our x value. Remember, 1, 0 is this first coordinate. Then we go all the way up here to the very top, and we're at our x value of 0, 1. Then we're going to be at -1, 0. And then we're going to be at 0, -1. Remember, these are x, y coordinates, and then we're going back to 1, 0. So once again, we're going this direction from our first quadrant to our fourth quadrant, and then around again. So if you think about this, cosine starts at 1, then goes to 0, then -1, then 0, and then back to 1 again. And that's exactly where these all come from. So if we look at it once more, after this 2 pi, we're going back to 0, then to -1, then to 0, then to 1 again. And that's another iteration. So how long does it take our cosine function to repeat itself? It looks like it takes every 2 pi rads for this function to repeat itself. So once again, this is 2 pi, this is 2 pi, and this is 1 rotation. Okay, so with this is going to be, once again, we're talking about your x values. Okay, this is referring to your x values. This next one's going to be referring to your y values. Now we're going to be looking at our sine. So these are your y values. Okay, we start at 0, then go to 1, then go to 0, then go to -1, then go to 0. We once again did a full rotation between 0 and 2 pi. This is 1 rotation. Okay, and then as we go, we're going to go ahead and take a look at our y values now. So with our y values, when you're taking a look at these, we start at 0, then go to 1, then go to 0, -1, 0. If you guys are looking at sine, 0, 1, 0, -1, 0. So it actually works out that same exact way. So what's going to happen, there are a few questions that you're going to be answering down below. The first one is going to be about how many full rotations are shown by the graphs. So we've already kind of talked about that in our first part, talking about cosine. And then after that, it's asking you a couple more questions that you guys are going to need to think about. When you're thinking about this last question, number 4, you're going to be doing all of these right after. How many angles show the point P at a height of 0.71? So if we're talking about height, are we talking about an x or y value? This means we're looking at our y values, or sine. Okay, so in this question, it's asking us how many different points meet our requirement of 0.71. Okay, how many points actually meet that? And you guys are going to have to go ahead and talk about that. Okay, so thank you very much, guys. Go and answer the question.